So I'm Pere Monclus. I'm the CTO in the Network and Advanced Security Group at VMware, and I'm going to cover a lot of portfolios. So I'm going to start very abstract, and the idea is to make it interactive. So if you ask questions, I can get deeper in specific capabilities, products, features, and so on. So maybe the first thing is like, what is this modern app transformation that we are experiencing? And if you think, as we go through organizations coming from more network security IT to cloud IT to DevSecOps, platform teams, developers, is a lot of territory to cover. So the way we approach it is depending on what's your point of view in a different way. And I'm going to cover those things. But essentially, if you take it from a modern app transformation point of view, is how do developers essentially rewrite those applications? What do they use? The commits, the libraries that they use. How do you get code scanners, artifact checking, and so on, in a way that we have kind of the shift left aspect of the security elements. So that's one vector that we are attacking. As we go into DevSecOps, now is a matter of how do you enable the transformation in terms of operational models? How do you guarantee that every time that the CI/CD pipeline runs and it requires like opening ports or connecting things or deploying things multi-cloud, you put all the pieces together? And then, of course, at the bottom layer, the infrastructure elements, right? How do you provision automatically everything that is needed as part of the continuous delivery aspects of the transformation? But if we go back to what those applications are requiring is different from what we are used to discuss. Like I was, I think, with some of you in a Cloudfield day a few years ago, and we were talking about how do we create network virtualization layers with IP address and microsegmentation rules and so on. And this is all good, but when we get into the modern app aspects, you may not see those. What you may see is an application that is exposed to the internet. You may have an SLO to monitor. And what happens if that SLO is not met? The SLO could be in terms of availability, but it could be in terms of security, compliance, script, and so on. So the type of things that start to matter at this level tend to be of higher nature. And this is where we get into APIs, traffic routing, circuit breaking, progressive rollouts, and what are the things that we need to do to provide all those capabilities. Of course, has to work across multiple clouds. And let's not forget that there's still a lot of infrastructure in our environments. And how do we bring all these pieces together? So if we think it like that, what happened is that the network has become a bit more complicated. And before I get into networking, let's try to understand why does it matter and to who. And this is probably the biggest shift. Until now, we were always approaching networking and communications and security almost like bottoms up. But if you think in terms of who's consuming an application that has been put in a multi-cloud environment, tends to be some sort of user that the only thing that cares is what experience am I getting? Now imagine that I'm popping up in the US or in Japan. Where is my application running? My experience may be completely different. So how do I figure out the aspects of TSLB, proximity, and so on? So this has to be hidden because as a user, I don't care about networking. Now you go one level down and you have the developers that they have to essentially create an application. They couldn't care less or they couldn't understand what components underneath are providing connectivity, security, and so on. They only care about application resilience. Is my app up or not? Am I going to be called to fix the problem or not? So how do I express those in terms of resiliency? Am I having the proper authentication authorization to my app? Am I leaking data in my APIs or not? So those are the things that matter at that layer. Now we go at the operations level, and you've seen all the talks from cloud health, secure state, and all the things that we've covered. And it's like, where is my app running? Is it in AWS? Is it in Google? Is it more expensive? Is it less expensive? Do I have local regulations, PCI compliance? So I have to put all these pieces together to make it work. And of course, the capacity aspects of infrastructure and the locations where you run. So if you think it from a networking point of view, we have evolved to kind of multiple layers of what networking means. Traditionally, we were living in kind of the network infrastructure layer, like speeds and feeds, cables, connectivity, switches, routers, logical switches, VPNs, and so on. But now we evolve over the years to this notion of network virtualization. And this in a form of how to create consistent operations regardless of where you run. Essentially, you may run into vendor A, vendor B from a physical networking point of view. You may run on public cloud, you may run in somewhere else. But now the thing is like, how do you secure end-to-end? How do you see end-to-end? How do you have load balancing end-to-end? So a lot of the products that we've been offering over the last few years are in that layer. You've seen and you've been exposed to things like NSX, NSX Advanced Load Balancer coming from AVI, distributed firewalls, and so on, SD-WANs. But now what we start to get is into this new world that we call modern app connectivity services. This is where you get things like traffic routing, end-to-end encryption, certificate management, circuit breaking, progressive rollouts, API discovery, API security, data tracking. And this is what we call kind of like a new modern networking stack. Now, the big aspect on everything we are doing and how we are getting into conversations with our customers and with the problems that we see is that there is a change in perspective. Now it's more about a top-down view of the problem. Before we were discussing a lot of, how do you put microsegmentation? Do you have a distributed firewall? Do you have like VPNs, and do you have a blast radius and things like that? Now it's like, how do I help as I transform into this modern apps journey to provide application resiliency across clouds? How do I have end-to-end encryption with proper certificate rotation? How do I do this GSLB automatic configuration to get closer to where the customers are? And the message of how networking is delivered is not anymore about features or capabilities, but the values that it provides through this modern app transformation. And this is how it's being articulated. Now, if we think like that, what are the challenges? Like we've been in this space of having our on-prem environments with perimeter firewalls, users in our enterprise campuses and so on for many years, but suddenly everything has changed. The applications have gone across multiple clouds, not only multiple clouds, but multiple form factors from Kubernetes to serverless to SaaS services, you name it. And what has happened is that essentially we have created, in a way, silos. Now, if you think when network virtualization started to transform the way networking was being done in the enterprises, we had like VLANs. And VLANs were containing an application, but you couldn't go beyond that aspect. And then we came with VXLANs, or network virtualization, and we essentially transformed the data center flat. We normalized the data center. But now we have silos again. We have VPCs, we have VNets, we have on-prem networks, we have Kubernetes, we have SaaS services. So it's how do we put it together again? What's the abstraction that allows us to do that? And of course, we have to have this in a way that we can have consistent operations, visibility, security, and so on. So most of our customers come to us and they say, look, what I would like is an abstraction, a concept that allows me to put and connect everything together across these heterogeneous environments, across all layers of the stack, from VMs to bare metals to serverless to SaaS services, with security and compliance, visibility, and so on. It's like, yeah, that's nice, but not so easy. And now the first thing is like back to the layers that I was discussing before. Sometimes we have to start thinking that not everything gets solved with the same technologies. And this is where, back to the previous discussion, we had this notion of how do we solve the problems from an infrastructure point of view? How do we have microsegmentations? How do we have DFWs? How do we have IPS IDS? But now with the modern capabilities that we are introducing, we can see what the top down of the application is happening. And this is where with products like Service Mesh, ingress controllers, and so on, now we have access to essentially what the users do with the app. We see authentication authorization, we see OAuth, we see TLS termination, we see API calls, we see what data flows through these API calls. So essentially what happens is that now we can complete the picture. Now you have how users, apps, and data interact at the application level, and how infrastructure components interact at the infrastructure level, at the IP address level, at the connectivity level. And the idea is now, how do you bring everything together? You'll see that with concepts like zero trust, end-to-end encryption, and so on, the way we secure multiple applications across environments is changing. And the upper layer allows us to essentially tap to that, because now when a user connects with an encrypted TLS tunnel to an application, now we can start seeing that this security model gets maintained end-to-end, or we can extend it up to app. And at the same time, look at the communications at the layer 7.
At some point, packets need to run on real wire and on real switches and real routers. So it sounds like what you're talking about is providing a consumption layer for applications to consume and users to consume that has a knowledge of the underlying infrastructure. But I would think that that has implications on the way the infrastructure folks need to design their networks and what parts of the puzzle they need to put into place to optimally provide that your consumption layer, right? You wouldn't design the physical infrastructure the same way. You kind of have to provide a lot more flexible optionality from an infrastructure perspective. Can you talk into
Yes.
you talk to what infrastructure people have to do to optimize to this new paradigm?
Yes. So let's assume that you have, back to the previous picture for a second, multiple environments. You have a data center on-prem and you have a public cloud. Let's use those two scenarios. The first thing that you would say is like, well, in my data center, I manage my network. I understand how to create my leaf-spine architectures, how to decide what level of oversubscription do I want. I have my network monitoring tools based on NetFlow, based on whatever, like I see packet losses, queue utilization, all those things. So I understand my physical infrastructure. But now I put, let's say, 2,000 applications on top because I'm a large financial institution. I have many apps. And the network layer tells me, oh, you're experiencing packet loss in this link. Should I panic or not? I don't know. Packet loss is bad, yeah, but is it affecting a production environment or a dev environment? I don't know. So the first answer to your question is, what the top-down view allows us is that this needle in the haystack problem is like things that from an infrastructure point of view, they are bad, do they matter? And maybe they don't matter, because if we start monitoring the application SLOs and we understand that an application is suffering, immediately back to the priority of what's important, what's not. If it's a dev application being run as a test case to see if we can commit the code, who cares? But if it's a prod, it's a big deal. So now the alerts can be triggered based on an app misbehaving, point to where this app is, look at the network virtualization layer, see the overlays, point to the physical network and understand that there was a packet loss in the link for an optic that was blurry, whatever. So in a way, it's not that the notion of understanding what your physical network is doing is not important, is that it allows you to see top down which ones to prioritize first from all the issues that you may have in the physical world.
I guess I'm thinking of it also more from an architectural perspective, right? Do I, in order to optimize for this world where I've got monolith, you know, the VMs, my multi-cloud, my on-prem, all the stuff that you've now connected here, am I better served as an architect now putting, say, SD-WAN nodes to Bellow Cloud, right? Adjacent to cloud, to multi-cloud points? Does this change where I put stuff?
Yes.
Versus, you know, the way I did it before?
Yes. Give me maybe 3 slides more and then I'll get
there.
Yes. But yeah, there is this aspect that one is back to the bottoms up. Do I have to think ahead? Where do I put my infrastructure, like in a Velo node versus this versus that? The other way of thinking it is like, if the top layer can see the SLOs and when the demand is, can I automatically expand to those resources available to the infrastructure? And you'll see that I'm taking more the second path.
Excellent, thank you.
Okay, so now if we get into this modern app security, right? Why does it matter? And back to the same, you're going to see that I keep going again and again, top down, top down, top down. It's like, in reality, security doesn't matter. Doesn't matter because if we do it in the abstract, it's like, what am I securing? What matters is like securing the applications that I'm trying to put in production, right? And if this is the case, it's like, what are we trying to achieve with these security elements? And it's this aspect of how do I bring enterprise agility? How do I move my applications that are being developed as fast as possible in a production environment with proper compliance, encryption, security, and the proper network experience? And of course, this to lead the developer productivity and so on. So again, the infrastructure is something that we put at the service of a bigger value. Now, if you think like that, what happens? Back to this question about the network. Before we get into the placement, there is another problem, which is like we have all these disparate components. We have from switches, routers, service meshes, ingress controllers, load balancers, DSLBs, and so on. And now it's like, I'm an enterprise, I'm trying to put all these pieces together. What do? Do I create experts on all these things and now I have to figure out how to put all the pieces together? Or is there another way? So the way we approached it, and we introduced a few bundles, what we do is figure out, at least for modern apps, how to bridge this gap. how to put all these pieces together in three major buckets. The first one is the application connectivity and resiliency. And I'm going to get into your question in a second. And the question was very clear, is like, sure, you want to put this application in production, but first, where do I put it? How do I know that the resources available underneath are proper? And how do I make the whole thing work as a system? The second aspect is security, but now not at the infrastructure level, but at the API level. Now, if you think most of the attacks that happened lately, including the Log4j vulnerability, or the Cambridge Analytica leak, or the T-Mobile leak, you name it, is always an API that for whatever reason has not been protected properly. So how do we monitor, how do we secure it, how do we understand what's going on? And the third is the operational aspect, is as we tackle this left problem, how do we solve it in an efficient manner? But from a security point of view, with this shift left mindset, security is not just in the runtime, starts at the build, and this is where you saw things like carbon black containers, like secure state, things like that. And as we propagate to the runtime, I'm going to focus more on that. So what do we do from a network and security point of view? So the first thing is this aspect of providing guardrails. And guardrails from the things that we discussed before in terms of what are the fundamental things in terms of microsegmentation, workload protection with endpoint security, ingress, egress management, and so on. But then we go to the level of compliance. How do I provide end-to-end encryption? And then we get at the level of APIs. And APIs, you're going to see that I will emphasize it again and again, because the APIs are the new endpoints in this new world. If we don't understand APIs, if we don't secure APIs, we are not securing anything. And this is where we bring this baselining, API discovery, cataloging, schema extraction, and so on. And then data matters. If we lose data, we have a problem. So all the PII, DLP capabilities that we are adding on top of our service mesh technologies or ingress, egress proxy technologies. Now, all these pieces come together, and at the same time, we have another problem, which is solving greenfield problems is fine, but a lot of the applications run somewhere else. So if you think the way we are approaching it is in this new modern apps world with Kubernetes environments, serverless, and so on, we have a set of technologies starting by protecting kind of the ingress, egress out of this new modern world with, for example, the NSX Advanced Load Balancer, AVI. And in there, what we do is a multi-cloud solution that gets centrally managed and expands across any cloud with essentially WAF, VSLV, and so on. We extended with service mesh. Now we have sidecars, proxies with the ability to do certificate management, MTLS, open the TCP connections, HTTP connections open, look at APIs, DLP, and so on. We complemented with Project Antrea, which essentially is microsegmentation, open source in Kubernetes, and we connected to existing workloads with NSX. And essentially, we provide a solution that end-to-end allows you to have a visibility of everything. What are the major use cases that we are seeing in this space? Why do customers come to us and we have discussions about what it means in terms of network and security? So the first one tends to be security and compliance. I'm going to this modern app transformation. I need to have like encryption. I need to understand if I'm properly protected at the web level and so on. How can you help me with that? And this is where we started providing with a combination of the AVI ingress and the service mesh, a lot of the aspects of this first bucket. And with the zero trust multi-cloud movement, even more accentuated. Another entry point is the fact I'm running this app and the experience is bad. And I don't know what's going on. And my front end is in Amazon, my back end is on-prem, my database is still a traditional database, and the experience is bad and I don't understand what's going on. So it's this aspect of starting to monitoring the SLO and peeling the onion until we find what the problem is. And the third is this, I want to go multi-cloud. My DevOps team and my developers want agility, but they will not accept opening a ticket to configure a VPN and open a firewall rule because this is going to take forever. How do I bring multi-cloud capabilities? So very high level, I'm going to explain how we solve that. And one concept that we have introduced with our modern app connectivity services, and is part of Service Mesh, is we created a concept that we call global namespace. Now, imagine that you are in Amazon and you have a VPC. Now, applications live inside a VPC, and a VPC lives inside an availability zone. Now, let's use Kubernetes. You have Kubernetes, you have a namespace, you deploy an application in a namespace. But now the application lives in a cluster. What if the cluster dies? The application is dead. So what we have introduced is a concept that is, what if you could have as many Kubernetes or modern apps clusters as you want underneath, and now we would create something called a global namespace that looks and feels and behaves as a namespace in a single Kubernetes cluster. You can deploy an app on it, and now automatically all the microservices in this global namespace are going to see each other as neighbors. They're going to do DNS lookups, they're going to be able to talk to them, they're going to have end-to-end encryption, but the reality is that they may be spread across multiple clusters. You may have 2 clusters for high availability, where now the global namespace presents a single atomic unit, and if one of the clusters dies, nothing happens because the other cluster is still alive. Or they could be across clouds. And the global namespace automatically takes care of certificate management. Basically provides a CA that now generates the certificates and rotates the certificates for all the endpoints part of the global namespace across any cloud. Provides DNS, it provides policies, it provides application monitoring, and so on. Now, with this, we provide SLO monitoring. Now I'm going to go to the question. So if you think the way it works is, so let's imagine that we have one cluster with one namespace, let's say in this case, Kubernetes, and you have an application that is deploying that namespace. So we create a global namespace that now you're going to see the application is living on top. Now, the moment you want to extend that application, you could add another cluster. And what's going to happen is that as this second cluster gets added, the namespace gets onboarded into this global namespace. The global namespace concept automatically configures the GSLB, automatically configures the certificates, the DNS entries. And now suddenly what has happened is that the global namespace expands and the application now lives in a resilient manner in 2 clusters. Let's assume that now you say, I ran out of capacity in my cloud and I need to add another cloud. So now you bring another cloud and automatically the global namespace extends the configuration, the certificate management, the GSLB, the traffic routes, everything. And now the global namespace expands across all that. Now the application can essentially live in multiple of them. We can create reliable patterns. And now back to your question. Imagine that what you have is a set of resources in VeloPops, in cloud environments, and so on. Now you put in the global namespace an SLO configuration. Imagine that you say, I want my application to always experience less than 300 milliseconds, 99 percentile latency. And you make it run in whatever resource you have available today, let's say AWS. Now traffic starts coming from US, everything is good, but suddenly Japan wakes up, users from Japan appear, they get routed to the US, the SLO gets violated. So automatically the DNS can say, I'm violating the SLO, I'm going to alert you, and we can do that, but then we can do auto scaling. And then what we are working on right now is like, what if we automatically trigger the creation on the standby cloud and cluster? So in a way that we cannot solve the infrastructure problems, but by taking the top-down approach, you can see what resources are available to you, and based on the SLO of the application, automatically trigger the instantiation of those resources. When we get into this modern app multi-cloud transformation, it's a top-down approach, and how the network and the security components provide integrated ways with the DevSecOps CI/CD pipelines approach in a way that now we can fulfill what the application needs to bring agility and developer productivity into the enterprise across any cloud.